Any decimal that has only a finite number of non-zero digits is a terminating decimal. If r and s are positive integers and the ratio r over s is expressed as a decimal, is r over s a terminating decimal? Well, in this problem, they're kind enough to tell you what a terminating decimal is and give you a couple examples, but really you need to understand the theory of terminating decimals before you can answer the question. So if we have a fraction r over s, what makes it a terminating decimal? Well, if the denominator, you look at the denominator and the only prime factors are 2's and 5's. And it doesn't matter, we could have as many 2's and as many 5's as we want, but we have no prime factors other than 2 or 5, then yes, the decimal terminates. Otherwise, no. Any other prime factors other than 2 and 5, you get a non-terminating decimal that goes on forever. For example, 1 over 3, that's a decimal that goes on forever. It's 3 repeating forever, a non-terminating decimal. So the whole question about whether a decimal is terminating or not boils down to whether the only prime factors in the denominator are made up of 2's and 5's. The numerator doesn't enter into it at all. So now we go to statement. Statement number 1 tells us that the numerator is greater than 90 and less than 100. Well, that's absolutely useless. That tells us absolutely nothing. So statement number 1 by itself is insufficient. Now statement number 2 tells us s equals 4. Well, of course, 4 is a number whose prime factors are 2 times 2. The only prime factors that appear in 4 are 2. And so that means that if we have a 4 in the denominator, we only have factors of 2 or 5 in the denominator. And so it means that any numerator divided by 4 will in fact be a terminating decimal. So this statement by itself is sufficient. Statement number 1 is insufficient. Statement number 2 is sufficient. Answer choice B.